Well, welcome back. This is the fourth video in the series dealing with the Eureka Tool. And what we're going to talk about today are these button tools. And I ended up making two of them. And I've configured them different ways and had a few problems here and there, and we'll get into that in a minute. But before we do that, I kind of wanted to go back to the last video and some changes and some things that I've done since then. If you remember, you have to make this cut here with the button tool. The button tool comes in and it makes a cut like that. And this proved to be a very difficult cut to make. This was the first attempt, and I didn't like the finish on it, so I made a few improvements, and I ended up cutting 5 more of these. And finally, the second one came out really well, but the third, fourth, and fifth one, I just kind of was trying stuff to see if there was an easier way to do it, and so on and so forth. Well, after the video last week, I had 6 of these, this one and 5 other ones, and I decided what the heck, and I went ahead and put the holes in them, and then cut them with a slit and saw, and then put them on the Eureka Tool, and I made 5 cutters out of it. It all started out, I made this one here, which was there's no relief in the edge here. I was just cutting just to see how the Eureka Tool worked, and the learning curve was pretty steep. It's hard to get used to, and so I just continued on, and so now I've got 5 of them under my belt, and I feel a lot better about how the machine works and everything like that. But I did a couple other things, and here, let's see if you remember this. Yeah, this was my attempt to temper the cutter after I made it. Well, I've made a few changes from there. Let's go back to the office for a minute. Okay, here's a look at the cutter. And what we got to do is get the cutting tips to light straw or 400 degrees Fahrenheit. It's best done in an oven. And I used the oven to do my hobs, and my wife wasn't real happy with that. And so getting them all done at the same time is rather difficult. But I came up with something new. Have a look at this. This is just a reenactment of how the new way that I used to temper it. I just simply took my torch and heated it down here, and you can actually watch the heat going up the pipe till it gets to the thing. And then when you see that the tips are hot, I just simply dropped it into the water, and that worked a whole lot better. It was pretty fast. But the best part of it is that I could do the hardening and the tempering all down here, one right after another, and it worked really well. Alright, so we're ready now to go ahead and start on these button tools. Before we do, I wanted to let you know that this is where I got the information. This is what got me all started. Ivan Law's book on gears and gear cutting. He's got all the drawings for the Eureka Tool. He's got the drawings for the button tool. He shows you, he talks about it, and gives you all the information that you need to get you serious about doing something like this. And then it wasn't long after that I ran across John Stevenson's work, and he ran the numbers, and he's got his own table here, and his table's based on a 20-degree pressure angle, and that wasn't what I wanted, but he has a lot of information on the button tool, and he's even got a part here at the end where if you don't want to do a Eureka Tool, he's got a way of offsetting a 4-tooth cutter that's very interesting. But when I was done, I needed a 14.5 degree pressure angle. I didn't really feel that I had the I could have done it maybe in AutoCAD, but I needed more info, and I found Mike's Workshop. and he's run all the numbers here and all the equations, and it's easy to follow along. He's got it all out there for you. And after doing that, at the end here, he's got a 14.5 pressure angle already, a table for it already right here. This is the one we're going to be using. And and he's also in his website. It's not here when you find this. It's another part of his website. But he's got a cutter that he's made. That's not a button tool, but using this same idea. And you should take a look at that as well. It's a single point cutter. It's a little bit different. But I could not have done any of this stuff that I'm messing around without these three guys. One guy wouldn't have worked. It had to be, I had to use all three of them pretty much almost equally. It came in, but that's how I managed to do it, and I didn't do any of the research. These guys did all that stuff. I'm just a guy building stuff here. And I really appreciate the work that they put into all this. So anyway, let's go ahead out to the drafting table. We'll run some numbers and then we'll start making some chips. We're out here at the drafting table because I'm hoping that it will allow me to keep, there it is, it allows me to keep it in focus. These are the three things that we need to know before we can work out the numbers. We need to know that we're going to be making a 24 pitch gear with a pressure angle of 14.5 and with 32 teeth. Now there are 8 cutters when you buy a set of gear cutters. The cutter that we're looking at is the number 4, and it cuts between 26 and 34 teeth. So it's accurate for 26 teeth, and then it's close enough for the rest here. So now we go on Mike's workshop, and using this information here, we go on to his little graph, and we came up with 6.510. That's our factor. We divide it by our pitch, which is 24, and we come out to 0.271, and that's going to be the diameter of our buttons. So now that we know that, we can go down into the shop and make some buttons. Okay, yeah, here's our AutoCAD rendition of the making of the buttons. The white lines represent the water hardening tool steel. It's 3/8 inch in diameter. And the first cut I'll make is I'll take out these the button. I'll make a diameter down to 0.27125, which is the diameter of these two buttons that we're going to be making. And then after I've done that, I'll cut this stem down here. And I think the stem is 3/16. When I finish the stem, I'll part it off here, flip it over end for end, and then I'll turn the stem on this side. Then we'll take it over to the bandsaw, cut it in half, and then we'll harden it and take a look at it. So let's go ahead down to the shop and get started on all that. Alright, we're starting off here with a piece of water hardening tools here in the bandsaw. I'll take it over to the lathe. Now we're cutting our outside diameter of 0.27125. Once that's completed, now we're cutting our stem on the end here. And we'll part that off now. And once we've got it parted off, we're going to switch it end for end and cut another stem on the other end. Now we're ready over at the bandsaw to cut it in half. There, we got it in half. Take it over and we'll start hardening it. Get it up to cherry red. This is water hardening, so we'll just dip it in the water here in a sec. There we go. Let's get a file and we'll give it a few scrapes here. Make sure everything's nice and hard. Yeah, it's just sliding over it. That's a nice finish. Alright, well there you go. There's the two buttons. So let's go ahead back out and do some more math and we'll start building the holder for them. Okay, we're back to the drafting table, and we're still working with the same parameters with the same number cutter. Now we're looking for our button spacing. I got 7.762 from Mike's Workshop's table, divided by the pitch. So we came out to 0.3234. That'll be our button spacing. The infeed from Mike's Workshop once again, divided by 24. That's the number we get there. Now our blank width will always be the 4 into the pitch, or 1/6, which is 0.166. So let's go ahead and take these numbers and we'll go to AutoCAD and I'll show you on some drawings what we're going to do with them. Okay, we've built our buttons and now we need a holder to put our buttons on. And this is a piece of cold rolled steel. We know that our buttons, the spacing between our buttons has to be 0.3234. And then this distance here from the end of our button in is called the in feed, is how far in you go in, and our in feed was 0.141. So now we've got those in there, but you just can't put them in there with just the straight. You'll look up here. We need to put a 4 to 5 degree incline here, so that when we put our button in, we've got a 4 or a 5 degree front rake. Okay, either 4 or 5 degrees works just fine. Now I found that some people wanted to have 0 top rake, so that it'd be just straight across here. You put it, when you grind it, you just grind it straight across. But I also saw that some people wanted a top rake of between 3 and 4 degrees. So in order to get that top rake, which is, you'll see, this is what this has, you have to grind a 9-degree incline on there. And in order to do that, I had to make another holder. So this holder here, the spacing is between, doesn't really matter, but they're put in at a 9 degree. So that when I clip it, I've got my 9 degrees. So that when I put it in here, I've got a front rake still of 4 degrees. And I've got a top rake of 4, I got my front rake of 5 degrees and I got my top rake of 4 degrees. Now, when you've done that, when you've got these done, you have to scribe a mark in your, this is leading towards the high point. So the high point of that button is right there. The high point of this button is right there. And so you'll see that in the end I scribe a line in the buttons that have the incline. Alright, I've got a piece of cold rolled steel here. You can see I've got 2 angles underneath it, 5 and a 4, so that we get the 9-degree angle onto our piece that we need to get the 4-degree top rake on our holder. Now we're just drilling 2 holes in here. We'll start with the starter bit here. And I'm drilling them out now. Now on this piece we're going to need to drill into the side and put a set screw there for when it goes onto the surface grinder. And there it is, the 2 buttons in place with the set screws holding it. And there it is, getting ground down to size on the surface grinder. So now we've got a 9-degree rake on those 2 buttons. So before we finish with them, we want to scribe a line on the back side pointing towards the high side, so that when we put them in, we can put the high side at a 45-degree angle in our holder. And there we go. I got another piece of the same size cold roll, but this time the angle bracket is only for 5 degrees, and that's going to allow us to have our 5-degree front rake on our button tool. And this time when we're drilling our holes, we've got to be real careful to get our spacing at 0.3234. between the two holes. So we're drilling them out. And just to make sure that we've got a really good fix after I've drilled them out here, I'm going to put a reamer in there and ream the hole out nice and round. Slitting saw is just opening up the section between the two holes in the holder. Get it in deep enough, and then we'll file the rest. Now I'm using a square file here, and I've got it angled down towards the bottom. And once I got that in there, I'm using triangular file just to get the rough edges off. And this is some Loctite. Hold them in place. You'll see that I put set screws in the side. Those set screws are not necessary. I didn't put them in the second one. You just don't need them. The buttons don't get hot or anything like that. There's no way that the Loctite was going to give up. So on the second holder, I didn't put any. Now I'm pointing the lines I scribed to the 45-degree angle. This is, I didn't show you making this, but this is the little arm that goes on to the button tool to connect the button tool with the Eureka tool. And those are the two finished button tools. And this first one here has the 4-degree top rake. And you can see that it's pointing out to the 45-degree angles. The other one's not like that at all. And this one we just grounded it flat on the top so that it's got 0 top rake. And you can see the 5-degree front rake. And those are the two holders that I'm going to be testing out. Alright, this is our first attempt using the quick change tool post. Now when you first start out, you're not taking that much metal away, so things went pretty well. And this is the slowest I could get the Atlas with the back gears. So we're slowly taking off the metal here. But you can see the way that tool post holds the button tool right out there to the left. And as you get deeper and deeper into the gear blank, that begins to create some problems. So let me fast forward this a little bit, and I didn't have to go too far forward to find it. There you go, see that? But you notice how it pulls down on the tool post. Yeah, see, like that? And that was happening. We're not even one quarter of the way in yet. The deeper you get in, the more and more area you have to remove. And the buttons on either side of the tool blank like that create a tough cutting environment. But that quick change tool post, I was going to draw it out in AutoCAD and show you the leverage. There it is again. But you can see it clear here. I got it in nice and close. If someone was to ask me, I'd say go with the 0 top rake cutter, and if you need the other one, make it. But no matter what kind of a gear cutter you're making, you're going to have to make a plunge cut. I've turned the volume down, you can't hear it squeaking. But when you make a plunge cut like this into tool steel, it's going to be a little bit of a challenge. But there you go. Okay, so there's the lantern tool post. First thing I use is an adjustable parallel to get it squared up, so it's nice and square to the chuck. Okay. And if you remember from AutoCAD, the infeed dimension is based on the outer edge of the buttons. So I just put a parallel in there, brought it into that till it was straight up and down, zeroed my dial indicator, brought it in the width of the parallel, and that was my 0 position. Put it on the dial indicator.
Okay, now we're ready to start. A little oil. And now I'm just lining up the edges so that they're cutting equally. Starting to get in there now. There we go. Now we're ready to go. I'm going to fast forward this up to nearer to the end. This went on for about, I don't know, 15 minutes.
I went on and made this gear cutter with that gear we were just working on. Came out fine. And I did make some changes to the holder. I went with a 5/16 fine as opposed to a 1/4 fine that I had before. The back gears put a lot of torque on this when you're cutting with that plunge cut into tool steel. The Tommy bars could no longer hold it. I couldn't get it open with the Tommy bars. So I put this 6-sided hex on here so I could get it off with a wrench. And then I took the whole piece, this whole piece, and I case hardened it. And that made a lot of difference. That made it much more usable. And then I went on and I got a piece of cold rolled steel and I cut this gear. And this next section I'll show you how I cut the gear.
Alright, so here I am turning down the OD. And you can see that the new holder, the changes in the holder are in there. You can see the 6-sided nut on the end. And it's just a piece of cold rolled steel that I had. So let's go ahead on to the actual gear cutting part.
We've got the cutter in my mill and my rotary table over here to the left. And I'm lining up the center of the rotary table, and this little white card will help, but you can see how I'm lining it up there. That's a little bit different from the way that I do it when I'm cutting clock gears. So if you want to see a different setup, I use the lathe and I cut the gear from right from the lathe rather than taking it off the lathe and moving it to the rotary table on the mill. But my rotary table here has a shoulder in here along with some threads, and the shoulder holds the 3-jaw chuck very, very, very accurately. I feel it's more than enough accuracy for an involute gear. So go ahead, let's go ahead and bring the 3-jaw chuck over and start cutting.
All right, we got into this movie of the cutting of the gear a little late. Most of the other ones that I shot were a little bit out of focus. This one's much better, so you get to see a little bit more of the true cutting of the gear.
Okay, here is the 24 pitch, 14.5 pressure angle, 32 tooth gear that I cut, and it's meshing with my Atlas gear from my Atlas lathe. It's also a 32 tooth 24 pitch, but it's 50 years old. But I'm really happy with the results. Let me see if I can get you some pictures here. And anyway, this is the last of the Eureka Tool videos. And I want to thank Joe from the YouTube channel My Heap, who suggested that I do this. I've really enjoyed it. I've had a good time. And I really feel that if you made it through all the videos, you should have a t-shirt or something. I'm sorry I can't get you one. But if you made it through all the videos, thanks a lot for watching. I really appreciate it. And I hope I'll see you guys again. Bye now.